Hello and welcome to the course, The Ultimate Beginner's Guide to Machine Learning. My name is Jones. I am the founder of AI Expert Academy platform, which is a membership platform with online courses on artificial intelligence, machine learning, data science, and all related topics. Nowadays, the area of artificial intelligence and machine learning is one of the most relevant in technology. Every day, more professionals in this area are required. So, the motivation for recording this free 2-hour course is that many students only need an overview of the area and do not have time to take a longer course, since a complete course on the subject would last at least 30 or 40 hours. This course covers the basics of machine learning, especially for those who need a quick and practical overview to understand the initial concepts. This course does not have any prerequisite, meaning anyone from any area can take it. Many students think that to work with machine learning, you need to know computer programming. However, nowadays there are several completely visual tools to develop your projects. Not a single line of code is necessary. Now, I'm going to show you the content that will be covered. You are going to learn the 4 main areas of machine learning. We are going to start with classification. The goal is to predict events in the future, and we are going to see 4 algorithms: naive Bayes, decision trees, rules, and support vector machines. You are going to learn the basic intuition about how the algorithms work, and right after we are going to move on to the implementation. The second main area of machine learning is regression. The goal is to predict numbers. For example, based on the expenses on the credit cards, you want to predict the new limit for the customer. You are going to learn the basic algorithm, which is linear regression. The third main area of machine learning is clustering, and you are going to learn k-means algorithm. Finally, in the last section of the course, you are going to learn about association rules and the a priori algorithm. The practical lectures will be done using the Orange tool, so no code is required. We just need to drag and drop the components on the screen, so it will be very easy to follow all the lectures. It is important to emphasize that there are many other algorithms and many other techniques within the area of machine learning. In this free 2-hour course, we will only cover some of them, as the objective is for you to only have a general overview of the area. After finishing the course, you can decide if you really like machine learning and take longer and more complete courses. We hope you enjoy this quick and free course and have a lot of ideas on how to apply machine learning in your own projects. See you in the next lecture. Hello and welcome to this lecture where you are going to understand what classification is. To work with this machine learning task, it is needed a historical dataset. We can consider this dataset. Let's suppose that it is from a bank. There are some features for each one of the customers of the bank. Each one of the rows is related to a customer. The first column is the credit history, and it can be bad, unknown, and good. Debts, high or low. Properties, if the customer has car, houses, or other type of equipment that can be used to guarantee a possible loan. And the possible values are none and good. And finally, the annual income, less than 15,000, between 15 and 35,000, and finally, greater than 35,000. These are the attributes or the features of the customer. In this example, there are only 4 columns. Of course, in a real scenario, it would have more data. And finally, we can take a look at the last column, which is the risk to give a loan to a customer. The possible values are high, moderate, and low. It is important to emphasize again that this is a historical data set, and the bank needs this data in order to train the algorithm. As we can see, this is called the training data set. All this data will be sent to a machine learning algorithm that is going to perform a lot of mathematical calculations to predict the risk of giving a loan to a certain customer. Another important concept is that the bank needs to create this data set, and all the rows are real customers of the bank. For example, let's suppose that this customer here, the first one, credit history is bad, high debts, no properties, and the income is less than 15. We can consider that this customer took out a loan in the bank and the risk is considered high. Let's suppose that he or she didn't pay the loan. So the risk was high in the past for a customer with these features. We can consider this other, the credit history, unknown, debts low, properties none, and the annual income greater than 35. This is the data of a real customer of the bank, and the risk was low. Let's suppose that the customer could pay all the loan with no problem. We have this other customer with this data, and the risk was moderate. Let's suppose that he or she paid some part of the loan and some of them were delayed. So the risk was moderate for this particular customer. It is important to emphasize that the bank needs to fill this data here. According to the data, it is going to analyze each one of the situations and specify the risk. This is a hard task since the data set needs to be made from scratch. The goal of classification is to predict the risk to give a loan. So we can see here some other clients that have just requested a loan. We can see the data, credit history, debts, properties, and income. But we don't know the risk. So when the algorithm is trained, each one of these customers is sent to the algorithm and it is going to return a prediction if the risk is high, moderate, or low. So the bank employee will decide if the loan will be granted to the customers. This is how classification task works. There is another example, the gender of the person, the country, the age, and the class is buy, if the customer is going or not to buy a certain product. Again, it is a historical data. For example, gender M from France, age 25, bought the products in the past. So we have this real customer. Another one, male from Germany, 21 years old, didn't buy the products. This is the training data that will be sent to a machine learning algorithm. And after that, we have some other new customers that actually we don't know if they are going to buy the products or not. So we can send this data to the algorithm that is going to return a prediction. In this case, yes or no. This is particularly useful because you can send only email to people that have more chances to buy the products. These examples are related to common data sets with features of people. It is also possible to use classification to classify images. An image is made of a lot of pixels. Each one of these points can be considered a pixel, and the set of pixels are used to make this image. In this example, there are 32 pixels in the horizontal axis and 32 pixels on the vertical axis. If you count, you are going to see that there are 32 by 32 pixels. We can multiply 32 by 32 equals 1024 pixels. When working with images, instead of sending to the algorithm the data about the people, such as the age, the credit history, the debts, and so on, the pixels are sent to the algorithm, so it will be able to classify the images. For example, we have this image laughing, but we could have another image of sad people, so the algorithm will receive the pixels and is going to classify. Another concept, when working with images, we use the RGB scale, the basic colors, red, green, and blue. And the goal is to classify or to separate the classes. Here we have the blue class, could be the people laughing, and the orange class could be the sad people or the sad images. That's all for this lecture, where you have learned the basic about classification. In the next one, we are going to start understanding the intuition about the algorithms. See you there! Hello and welcome to this lecture, where you are going to understand the brief intuition about naive Bayes algorithm. It is an algorithm based on statistics. As you already know, to build a machine learning algorithm, we need a historical data set. This is the same we were discussing in the last lecture about the bank. There are some features for each one of the customers: the credit history, the debts, properties, and income. The goal is to predict the risk to give a loan to a customer. We need this historical data set to send it to a machine learning algorithm, and some mathematical calculations are going to be made. Considering naive Bayes, the learning process is the creation of this table with probabilities. We can see here the credit history, debts, properties, and the income. And we are separating by the class, which is the risk. There are 3 values for the risk: high, moderate, and low, as we can see here in the rows. High, moderate, and low. 6 divided by 14 means that there are 6 people with high risk in the dataset. We can count here 1, 2, 3, 4, 5, 6. 14 means the total number of rows in the dataset. Considering risk moderate, there are 3 people, 1, 2, and 3. Finally, risk low, 1, 2, 3, 4, 5. 5 divided by 14. Now we need to consider each one of the values of each one of the features. For example, credit history, there are 3 values: bad, unknown, and good. We are separating them here. Number 5 means that there are 5 people with credit history equals to good. For example, we can count here 1, 2, 3, 4, 5. Unknown, 1, 2, 3, 4, 5. Bad, 1, 2, 3, 4. So we need to specify the corresponding values here. The same for the other features, like debts, properties, and income. If you want, you can pause the video and count the number of each one of these values, considering each one of the features. Now we need to separate the values, considering the intersection here. For example, risk high and credit history good. Only one person. So we can see here that the credit history good and the risk high is only this one I am pointing the mouse. 1 divided by 6. Regarding unknown, 2 divided by 6, because there are 2 people with unknown credit history and risk high. This one here and this one here. And finally, 3 divided by 6. There are 3 people with credit history bad and risk high. As we can see here, bad and high, bad and high here, and finally, the last one, bad and high. If we add 1, 2, and 3, the result is 6. The total amount of risk equals to high. Then we need the probabilities for risk moderate, credit history good, unknown, bad, risk low and good, low and unknown, low and bad. And we keep the same for the other attributes. Again, if you want, you can pause the video and check all the values. This is the learning process of naive Bayes algorithm. You send the historical data and a probability table is built. If you want to classify a new customer that has just arrived in the bank, you need to use this table. For example, let's suppose that the new customer has these attributes: history good, debts high, properties none, income equal or greater to 35. we don't know what class the new customer belongs to, so we need to perform some calculations considering the table. We need the probabilities for the risk to be high, so we can use the value 6 divided by 14, it is the probability of being high, and multiply by 1 divided by 6, because the history is good, so we are taking this value here, and multiply by debts equals high, 4 divided by 6, as we have here, properties none, 6 divided by 6, and finally, income equal or greater to 35. 1 divided by 6. We just multiply all the probabilities. The value is 0.0079. Now we need the same for the other classes. The probability for the risk to be moderate, 3 divided by 14, history good and moderate, 1 divided by 3, debts high, 1 divided by 3, properties none, 2 divided by 3, and finally, income greater than 35, 1 divided by 3. We just multiply the values and this is the result. Now we need to calculate the risk to be low. 5 divided by 14 times 3 divided by 5. This value here. Debts high, 2 divided by 5. Properties none, 3 divided by 5 times 5 divided by 5. The value is 0.0514. This customer will be classified as risk equals to low since this is the higher value. This is the process of classification using this algorithm. The historical data is sent to the algorithm, a probability table will be created, and then when we need to classify a new customer, we just take the data about the customer and multiply the corresponding values. If we want the results as probabilities, we just add all of them, 0.0645, and then we just divide the results by the sum multiplied by 100. This is the probability of risk equals to high, 12%, 8% of being moderate, finally 79% of being low. This is the naive Bayes algorithm. That's all for this lecture. See you next time. Hello and welcome to this lecture where we are going to start the implementation of the machine learning algorithms. We are going to use Orange tool. It is one of the simplest ways to start projects using machine learning. You can access the official website orangedatamining.com. If you want, you can navigate through this website to see more information and tutorials about the tool. We need to click here, Download Orange. It is possible to download the tool according to your operational system. After clicking this button, a file will be downloaded and you just need to execute it and follow the instructions. I'm not going to show this process step by step because it is a matter of following the instructions on the screen. After Orange is installed, you have access to this window. On the left panel, we can see all the components that are used to build the projects. And on the right side, on this whiteboard, we are going to drag and drop the components. The first step is related to data. It is possible to load CSV files as well as SQL tables. The next step is transform. It is possible to perform some operations on data, visualize. There are some different types of plots, model. In this step, we can see all the algorithms. For example, logistic regression, random forest, gradient boosting, as well as naive Bayes that we are going to use in this lecture. The next step is related to evaluate the models. After the model or the algorithm is trained, we need to evaluate it in order to check if the performance is good. And finally, the last one is related to unsupervised learning. In this lecture, we are going to start by testing naive Bayes algorithm. We are going to drag and drop the dataset's components. There are some ready-to-use datasets, so we don't need to load or to build our custom data. Double-click, we can see here a list of the available datasets, as well as the description. As we can see, there are a lot of different datasets, and the one we are going to use during the lectures, it is Zoo, a dataset that contains 17 binary attributes that describe animals. Features include information about presence of hair, feathers, and teeth, report if animal is aquatic or airborne, and alike. Animals are named and are classified into 7 categories: amphibian, bird, fish, insect, invertebrate, mammal, and reptile. These are the classes or the objective of the classification. Based on the information about the animals, the goal is to classify the type or the category. Double-click in the dataset. We can see that it has started downloading. You can see this green circle next to the dataset, which means that it has been successfully downloaded. Now we can visualize the data. We can use these other components, data table, drag and drop, and we just need to connect them. Double-click, see here all the data that it is available. 100 instances, 16 features. We can see here the class or the goal of the classification, the type of the animal, mammal, fish, bird, invertebrates, and so on. And here are all the attributes: hair, yes or no; feathers, yes or no; eggs, milk; airborne, aquatic; predator, tooth, backbone; briefs, venomous, fins; the number of legs; tail, domestic, and finally cat size. Based on all these features of the animals, the goal is to classify the type. We can visualize statistics about the data by using the distribution components in the Visualize tab. So we just need to drag and drop and connect them. Double-click. We can visualize some graphs about the data. We can see here that it is possible to split the data by any column we want. For example, we want to split the data by the type of the animal, which is the class. So now it is possible to visualize the frequency on the y-axis and the hair attribute that is selected here, along with the values. For example, hair equals to no and hair equals to yes. We can see the colors of each one of the classes. For example, bird is in red color, as we can visualize here. It means that all birds don't have hair. We can see other attributes. For example, now bird is in the yes part of x-axis, since all birds have feathers. If you want, you can select each one of the attributes in order to visualize the data. It is a very interesting tool since you can extract some initial insights about the data. The next step is to open the Model tab. Let's select and drag and drop the naive Bayes algorithm, and we just need to connect the components. When the components are connected, it means that the training has started. Just a reminder that in naive Bayes algorithm, the training step is to create the probability table. We can double-click. No parameter is available for this algorithm. Now we can visualize the results. We can go to Evaluate tab, Test and Score, connect the components, double-click. No result has been shown here because we also need to connect the data to test score. Double-click on test score. See here that there are two options to train the algorithm. The first one, the default, is cross-validation. We are going to see more details about it later on in this section. I'm going to use the second option, which is the random sampling. We can visualize here the training set size. I will change to 80%. It means that 80% of the data is going to be used to create the probability table, and 20% of the data is going to be used to evaluate the algorithm. Just a reminder, let's suppose that this data here is equivalent to 80%. They are going to be used to train the algorithm. After it is trained, we need different data to evaluate it, so we can measure the performance. Let's suppose that all this data here is used to evaluate it. It can be 20% of the data, so we just need to send each one of these instances to the algorithm in order to classify them. We have here the original data, the probability table is created, and then when we have a new customer that has just arrived in the bank, we need to perform the calculations to classify the risk, high, moderate, or low, as you have learned in previous lectures. In this case, we can see that this customer will be classified as risk equals to low. In this example, 80% of the data is being selected to create the probability table, and 20% of the data is selected to evaluate, or in other words, 20% of the data will be sent to the probability table and the probability calculations will be performed. It means that a probability will be generated for each one of the classes. Just a reminder that there are 7 different classes in this dataset. See here that there are 100 instances. It means that 80 instances will be used for training and 20 instances will be used for testing. Let's go back to test and score. There are some metrics to evaluate the algorithm. In these lectures, we are going to use CA, which means the classification accuracy. The result is 90%. To better understand this metric, we can use this other component, which is the confusion matrix. Connect then, double-click, and see here that now it will be easier to see the results. This result is considering all the data. And see here the intersection between the classes. For example, amphibian and amphibian. Number 10 means that there are 10 amphibian animals in the data and all of them have been correctly classified as amphibian. Number zeros here means the errors. For example, number 0 in the intersection between amphibian and bird means that there are 0 amphibians in the dataset that have been classified as bird, as well as 0 amphibians in the dataset that have been classified as fish. Regarding bird, 40 and zeros to the left and to the right. It means that all birds have been correctly classified, as well as the fish, the insects, and we can see here the invertebrates. We can visualize here the intersection. Number 8 means that 8 invertebrates animals have been correctly classified as invertebrate, but there are some errors in the classification. 7 invertebrates have been classified as insects. 5 invertebrates have been wrongly classified as reptile. Regarding mammal, 76 mammals have been correctly classified as mammal. Only 1 mammal has been classified as reptile. 3 mammals have been classified as amphibian. And finally, we can visualize the intersection between reptile and reptile, the row and the column. 6 means that 6 reptiles have been correctly classified as reptiles and 4 reptiles have been wrongly classified as amphibian. The confusion matrix is very useful to evaluate the performance of each one of the classes. And regarding the value 90%, it means that the algorithm was able to classify 90% of the data. In the next lectures, we are going to compare this metric with the other algorithms, so we can choose the best one according to the dataset. If you are satisfied with the results, we can save the model. It is also possible to just click here and the available components will be shown. We can click here on Save Model. We can click on Save, for example, the name, Naive Base, and you need to specify the location. Click on Save. What we can do after the model is saved, use these components, load model, double click, Here we just need to select the folder, select the file. What we can do after is to use another component. The name is predictions. And we just need to send the data. Let's suppose that you have new data that you do not know the class the animals belongs to. So you just connect your data to the predictions component. When we open it, we can visualize the predictions for each one of the classes. For example, the first one, we have here that the type is mammal and the prediction is mammal. It is correct. Mammal and mammal, fish and fish, mammal, and so on. To evaluate the algorithm, we can compare the class that is already available in the dataset with the prediction. We can see one error here. The type in the dataset is mammal, but the prediction is reptile. Another error here, mammal and reptile, mammal and amphibian. This is how it is possible to calculate the classification accuracy, since the real class of the animal is present on the dataset. Basically, a comparison is made between the original data and the predictions of the algorithm. We compare both values in order to have classification accuracy. That's all for this lecture. See you next time. Hello and welcome to this lecture, where you are going to understand the brief introduction to other machine learning algorithm, which is decision tree. We are going to consider the same data set. There are some features of the customers, credit history, debts, properties, and income. The goal is to predict the risk to give a loan to a customer, high, moderate, and low. In the naive Bayes algorithm, a probability table is created. On the other hand, when working with decision trees, a tree is created, similar to this one here. We can see that the income is at the top of the tree. Then we have the credit history, debts, the credit history here again, and see the rectangles at the ends. That means the classes or the risk, high, moderate, or low. A lot of mathematical calculations are performed in order to build this tree. I'm not going to go into detail about the math, but if you want to search, there are basically two math calculations that are performed: the entropy and the information gain. The most significant features are at the top of the tree. Let's suppose a new customer has just arrived in the bank and he or she is requesting a loan. The history is good, debts high, properties none, income greater than 35. Now we just need to follow the tree. See that the first attribute is the income, and the value is greater than 35. So we go to the right part of the tree, because to the left is when income is less than 15, to the center between 15 and 35, and to the right greater than 35. When we go to this side, we need to check another feature, which is the credit history. See here that the value is good for this client. So we go to the left part of the tree, and here at the end or at the leaf of the tree, the risk is equal to low. So this customer will be classified as low. See that the debts and also the properties are not used in this classification, since both features are not in the right part of the tree. Something very interesting is that properties is not present in the tree, since after the mathematical calculations, this attribute was considered not to be relevant to classify the risk. Let's suppose a new customer has just arrived in the bank with the following values: history bad, debts high, properties good, income less than 15. As we know, the first attribute to be verified is the income. See here that the income is less than 15. So we go to the left part of the tree, and here is the result. The risk is equal to high. For this particular customer, the history and the debts are not taken into account in the classification. This is how decision tree works. The data is sent to the algorithm after the mathematical calculations. A tree is created, and to classify new customers, you just need to take the data of the customer and follow the tree until you get to a leaf node. See you next time! Hello and welcome to this lecture where we are going to test decision tree algorithm. The first step is to load the datasets. We are going to use zoo dataset, just a reminder, based on the data about the animals, hair, feathers, eggs, milk, and so on. The goal is to predict the type: mammal, fish, bird, invertebrate, amphibian, insect, and reptile. There are 7 different classes. What we need to do now is to go to the Model tab and select the tree algorithm. We just need to connect the datasets to the tree component. When we connect them, the training process will be made. Just a reminder that in this type of algorithm, the goal is to use a lot of mathematical calculations to create a tree. Double-click in the components. We can see here some parameters that can be set to the algorithm. Let's go to the Evaluate tab, Test and Score, connect the tree to the components, as well as connect the datasets to the components. Double-click. We are going to use again the random sampling technique. The training set size is 80%. It means that 80% of the data is going to be used in the training process, which means the creation of the tree, and the other 20% of the data is going to be used to test the algorithm. We can see here the classification accuracy, 89%, a very similar result to the naive Bayes. What we can do now is to visualize the confusion matrix, double-click, and here we have all the information about each one of the classes. Just a reminder that the confusion matrix is very interesting to evaluate the performance considering all the classes. For example, regarding amphibian class, 6 instances have been correctly classified, the intersection between amphibian and amphibian. On the other hand, 4 amphibians have been wrongly classified as reptile. As you could see, the process of adding the components is the same for all algorithms. See you in the next lecture. Hello and welcome to this lecture where you are going to understand the brief introduction to another type of machine learning algorithm, which is rule-based learning. Again, we have this data set, the credit history, debts, properties, and income, the features about the customer, the historical data. The goal is to predict the risk, if it is high, moderate, or low. When working with this type of algorithm, all the data is sent to the rule-based algorithm, and as the name suggests, rules will be generated after some mathematical calculations. There are 2 examples here. If income equal or greater to 35 and the credit history is equal to good, then the risk is low. The second rule, if income is greater or equal to 35 and the credit history is unknown, the risk will be also low. We can see here the default rule, the risk is high. In other words, if none of the 2 first rules are executed, then the default rule is executed. In this example, there are only 2 rules, but of course, in a real scenario, more rules will be generated. To classify a new customer that has just arrived in the bank, we need to take the values and try to execute the rules. For example, if income is equal or greater to 35, see that income is equal or greater to 35 for this customer, and the credit history is equal to good. We can see that the history is good, then the result or the risk is equal to low. This new customer will be classified as low. Similar to decision trees, see here that debts and properties are not being used for classification, since they are not considered important enough to classify the customers. Let's consider another one. History bad, debts high, properties good, income less or equal to 15. We need to try to apply the first rule. If income equal or greater to 35, see that this part of the rule is false, since income is less than 15 for the new customer, and credit history is good. The credit history is bad. It means that the first rule will not be executed. Then we need to try to run rule number 2. If income is greater or equal to 35, this condition is false, so the rule will not be executed, and finally, the default rule will be executed since the first 2 have not been executed. This customer will be classified as high. This is how this other type of learning works. The data is sent to the algorithm. Some mathematical calculations are performed in order to generate a set of rules. When a new customer comes to the bank, the rules are executed in order to check the risk. See you next time! Hello and welcome to this lecture, where we are going to test an algorithm based on rules. The first step is to load the dataset. We are going to use again the zoo dataset. Just a reminder, we can add a data table component based on the features about the animals. The goal is to predict the type, such as mammal, fish, bird, invertebrates, and so on. Open the Model tab. We can see these components, CN2 Rule Induction. CN2 is the name of the algorithm. Double-click. We can visualize some parameters of the algorithm. We just need to connect datasets to the rule induction, and then we can evaluate the results. Test score, connect the rule induction components to the test score components, as well as the dataset needs to be connected to the test and score components. Double-click. We are using 80% of the data to train and 20% of the data to test. Just a reminder that the goal of this algorithm is to analyze the data, perform some mathematical calculations, and generate rules. We can see that the classification accuracy is better if compared to the naive Bayes and also to the decision tree algorithm. 94% accuracy. We can also visualize the rules that have been generated. We can open Visualize tab and select CN2 Rule Viewer. We just connect the components, double-click, and here are the rules that have been generated. If feeder different from null, then the class is bird. We have here information about the distribution and the probabilities. The other rule, if milk different from null, the type is mammal. Hair different from null, the type is insect. Airborne different from null, the type is also insect, and so on. Here at the end, we have the default rule. When making a prediction, if none of these rules are executed, then the default rule is executed, so the type will be mammal. We can also visualize the confusion matrix if you want more information about the performance of each one of the classes. See you in the next lecture. Hello and welcome to this lecture where you are going to learn the brief introduction to another type of machine learning algorithm, which is support vector machines, SVM. We can see here the blue or the black points on the left and the white points on the right. Basically, all classification algorithms needs to separate the data into classes to be able to classify if it is blue or black or if it is white. The straight line to separate the classes is created after some mathematical calculations, and there may exist different lines to separate the data, as we can see in this example, and also as we can see here in this example. The data can be the same, but there are different straight lines that can be used to classify the data. We can see here more than 10 different lines that can be calculated in order to classify the data. And the goal of support vector machines is to perform a lot of mathematical calculations to find the best straight line that can be used to classify the data. We can see here that this was found to be the best one, and as we can see, there are some margins here, which are called the maximum margins, that touches the points in each one of the classes. And these points here are called SV, the name of the algorithm. They are the support vectors or the support points or instances of the datasets that are used in the calculations to find the best straight line to classify the data. There are a lot of mathematical background in this algorithm. The calculations are very complex, and we are not going to cover them in this lecture. The idea is just to have an overview of how support vector machines work. Basically, the algorithm aims to find the best straight line to classify the data. That's all for this lecture. See you next time. Hello and welcome to this lecture where we are going to test SVM algorithm. We first need to load the dataset, which is zoo. Just a reminder again, I'm going to add the data table component to visualize the data. The goal is to use the features about the animals to predict the type. If the animal is mammal, fish, bird, invertebrate, and so on. I'm going to open the Model tab. We can visualize here SVM algorithm. We just need to connect the components, double-click. We can see some parameters that can be set. The mathematical background of this algorithm is very complex. There are a lot of concepts such as cost and kernel. If you want, you can change the parameters and compare the results. What I'm going to do now is to evaluate using test and score components, connect the datasets to test and score, double-click, we can visualize the classification accuracy, 93%. Just a reminder, we are using 80% of the data to train in this algorithm is to find the best straight line to separate the data. To evaluate the algorithm, we are using 20% of the data. Finally, we can visualize the confusion matrix so we can compare the performance considering each one of the classes. See you next time! Hello and welcome to this lecture where you are going to learn a brief introduction to regression. Classification is used to predict classes. For example, predict the risk to give a loan to a customer. High risk, medium risk, or low risk. On the other hand, regression is used for prediction, but prediction of numbers. There are some examples based on the advertising costs. The goal is to predict the sales. Both are numerical variables. This is X variable and the result is Y variable. Another example, based on the temperature, humidity, and air pressure, X variables, the goal is to predict wind speed, which is Y variable. Based on the external factors, the goal is to predict the dollar price. Based on the exam results, the objective is to predict a probability that a patient survives, variable y. Another example, prediction of risk of investments based on the credit card spending and the history of the customer. The goal is to predict the new limit for the credit card. Based on previous values, the objective is to predict the product values, the new prices for the products. And the result of all of them, variable y, is a number. This is the main difference between classification and regression. We can see here this image. In classification, we need to identify the classes. On the other hand, in regression, we need to predict numbers. In the next lecture, you are going to understand a brief introduction to linear regression, which is one of the most common algorithms for this task. See you there! Hello and welcome to this lecture, where you are going to learn a brief introduction to linear regression, which is one of the most common algorithms to predict numbers. Let's consider this graph here. In the x-axis, we have the age of the person. On y-axis, we have the health plan cost. We can visualize here some values: 18 years old, 66 years old, and so on. Here, 800, 1600, and so on. There are some instances here. For example, this point is a 16 or 17 years old person, and the cost of the health plan is about 800. This is another person. He or she is in his or her 30s, and the cost is about 1,500. This other point, a person in his or her 50s, and the cost is about 1,700. A 70 years old person, and the cost more than 4,000. As you can see, the older you are, the higher the cost. The objective of linear regression is to find a linear relation between the attributes. The higher the age, the higher the cost. We can visualize here this equation. If you know something about mathematics, you know that this is the line equation. Letter y is the cost prediction, or in short, the result we are looking for. The goal is to send the age in order to get the price. At the end, x1 is the age of the person. So we just put here in this equation the age, perform this calculation to get the cost prediction. Regarding B0 and B1, the first one is a constant and the second one is called coefficient. Based on this equation, we can draw this straight line that needs to be close of the most points of the data. Regarding B0 and B1, they define the location of the line. In short, both parameters are used to draw the straight line. This is the training step in linear regression. A lot of mathematical calculations are going to be made to find the best values for B0 and for B1. B0 is the starting point of the line, and now we also need B1. We can consider here that the line goes from left to right. We can draw this straight line until it touches the line. This arrow is considered the slope of the line. In this example, parameter B1 could be 1750, and it is related to the line slope, how much the line is going up. In short, the process of linear regression is the following. Data is sent to the algorithm. A lot of mathematical calculations are performed in order to find B0 and B1. This is the training process of the algorithm. There are two types of linear regression. The simple linear regression, it is the same equation here, and you use it when there is only one variable. In this case, based on the age, we want to predict the cost. But in a real situation, there will be more variables. So, we use multiple linear regression. Y equals to B0, the constant, plus B1 times X1. X1 could be the age, and B1 is the coefficient. We add B2 times X2. X2 could be another attribute of the client. For example, the health history. Then we need another coefficient. In short, if there are 10 attributes, we need 10 coefficients. Just a reminder that during training, the algorithm will find the best coefficients for each one of the features. In the next lecture, we are going to implement linear regression using Orange. That's all for this lecture. See you next time. Hello and welcome to this lecture where we are going to test linear regression using Orange. The first step is to load the datasets. I'm going to use these components. In the list of datasets, we can visualize the target column. We can see categorical, that are datasets for classification. When you see numeric, it means that the dataset is used for regression, since a number is going to be predicted. We can order the datasets and see the list of the available ones for regression. We are going to use this one, imports 1985. If you want more detail, you can read the description and follow the link. Double-click to download it. Now we can visualize some of the data using the data table component. The goal of this dataset is to predict the price of cars based on the features. For example, we have the make attribute. It is like the brand of the car, Audi, BMW, and so on. Fuel type, aspiration, number of doors, for example, 2 doors, 4 doors, body style, drive wheels, wheelbase, length, width, height, and a lot of different attributes. What is important to emphasize is that all these attributes will be used to predict the price of the car. There are 205 different cars, 25 features, and see here that 1.1% of the data is missing. As we can see this interrogation mark, it means that there is no information about these attributes. If you want to see more details, we can use data info component so we can see the size of the dataset and the features. 11 categorical and 14 numeric. Regarding targets, it is a numeric target variable. Now we go to the Model tab. Let's use the algorithm, linear regression, connect the dataset to the algorithm. If you want, you can double-click and see some parameters that can be set. All the process is the same for the classification algorithms. Now we need to test and score, connect the components, then we connect the datasets into test and score, double-click, and here is the result. It is different if we compare to classification. The metrics are not the same. We can see MSE, mean squared error, root mean squared error, and mean absolute error. The easiest to understand is the mean absolute error, which is the absolute difference between the real price and the predicted price. When I say absolute difference, it means that we don't consider if the number is positive or negative. A metric, let's say that it's similar to interpret like the classification accuracy, is the R2, coefficient of determination. The higher the value, the closer to 1, the best the result. We can see that the result is 0.88. It can be considered a good result. This value is in the range from 0 to 1. The closer to 1, the better the result. If you have values from 0.75, it means it is a strong correlation between the attributes. At the left part, you can also use cross-validation as well as the random sampling. In this case, 80% of the data is used for training. Just a reminder that the training process in linear regression is to find B0 and B1 parameters. As there are more attributes in the dataset, a coefficient will be calculated for each one of the attributes. To better understand the mean absolute error, we can drag and drop the predictions components. We connect the algorithm to the prediction and also connect the dataset. When we connect them, all the data will be sent to the algorithm and a prediction is going to be made. We can see this yellow symbol. It means that instances with missing targets are ignored. Orange is going to delete these instances. When we open it, we can take a look at the real price. For example, this is the price for the first car, and this is the prediction of the algorithm. The error is 1702. In the calculator, just to make sure it is correct, this is the prediction minus the real value. We can see here that the result is 1702. This is considered to be the error. Regarding the other car, this is the real price, and this was the prediction. Real price and prediction, real price and prediction. To calculate the mean absolute error, we just add all these values without considering if the number is positive or negative, and we just divide by the quantity. We can see here that the mean absolute error is 1070. Basically, it means that when you use this algorithm to make a new prediction, the error will be similar to this one. For example, if the real price is 14, the prediction could be 13 or 15, 1,000 up or 1,000 down. When you are satisfied with the results, you can use Safe Model Component, so it is possible to use this algorithm in other projects. That's all for this lecture. See you next time! Hello and welcome to this lecture, where you are going to learn about a machine learning technique called clustering. The idea of this technique, as the name suggests, is to cluster the data to find patterns. We can use it in market segmentation to find out which customers are likely to buy some kind of product, as you can read here. So, you can cluster customers according to their preferences. Another application is the clustering of texts, documents, or news. For example, you can send texts about different topics to the algorithm, about politics, sports, foods, economics, and so on. And the algorithm will build the clusters based on the topics or content of the texts. Other applications: clustering similar products or customer profiles. For example, Netflix can cluster users based on their tastes about the movies and series they watch, so they can send better recommendations. Finally, another example is the application in social networks to cluster people with similar features. This image shows an example of clustering the data into 5 clusters. Each cluster has a different color, as you can see. There is a concentration of data in each part of the graph. For example, here are the instances that belong to cluster 0 in blue. Here at the bottom, the data regarding cluster 1, the orange color, and so on. This is an example of another course that we have where we clustered papers on COVID-19. For example, green could be articles about vaccines, red could be articles about side effects, and so on. This image shows an example from another course where we clustered soccer players. See that this cluster, number 1, is far from the others, which are the goalkeeper data, which has different features from the other players. That's all for this quick lecture where you have learned some basic concepts about clustering. See you next time! Hello and welcome to this lecture, where you are going to learn the basic intuition about k-means, which is the classic algorithm in this area and one of the most used. This image shows the data of people on the x-axis, the age, and on the y-axis, the salary. We will consider only 2 attributes to be easier to understand. The goal is to cluster the data based on these 2 attributes, salary and age. In this algorithm, you must define the number of clusters, 3 in this example. After the number of clusters is defined, the algorithm will choose 3 random centroids in each of these positions. Here, the green one, here the blue one, and here the red one. Of course, each time the algorithm is initialized, new centroids are generated in different positions. The next step is to calculate the distance from all points to each of the three centroids. For example, the algorithm will calculate the distance from this point here, where I am pointing the mouse, to the green centroid, to the blue centroid, and to the red centroid. After the calculation, we select the centroid that has the smallest distance, which indicates the greatest similarity between them. In this case, the smallest distance is for the green centroid, so this point will be part of the green cluster here. The distance calculation is repeated for all points, and the clusters are defined according to the smallest distance. For example, this point here is closer to the blue centroid, so it will be inside the blue cluster, and all these other points here will be part of the blue cluster. On the other hand, this point here is closer to the red centroid, so it will be inside the red cluster. Finally, we have the initial representation of the first clusters, the green, the blue, and the red. After the first calculation, we need to calculate the average of all points of the first centroid, so it will be positioned here. We do the same calculation for the red centroid, so the new centroid will be here, the average of all the red points. We repeat the same calculation to the blue centroid, so we calculate the average of the blue points, and as a result, we have the new centroid. It is important to emphasize that we perform the average calculation considering only the points that belong to the cluster. For example, to calculate the green centroids, we consider only these 3 points. The same for the red centroids, we consider the 6 points here, and for the blue centroids, the 6 points here. When the new centroids are defined, we need to repeat all the calculations again. For example, we get the distance from these red points to the green, to the blue, and to the red centroid. See that the point is closer to the green centroid, so these points will now be in the green cluster and no longer in the red cluster. This is the basic intuition of the K-means algorithm. The calculations are repeated several times until there is no more cluster exchange. See you next time!
Hello and welcome to this lecture, where you are going to learn how to cluster datasets using Orange. We are going to get the dataset's components, double-click, and for this test, we are going to use the iris dataset. Double-click to download it. We can visualize some information, data info. There are only 150 rows, 5 columns, and all features are numeric, and the target is a categorical variable with 3 classes. Just a reminder that in this lecture we are not going to work with classification. We can visualize the data. We can see here 3 types of classes: iris setosa, iris versicolor, and virginica. The goal of this dataset is to use the data about the flowers, the sepal length, sepal width, petal length, and petal width to classify the type of the flower. I have opened the Google image search. We can visualize the details about the classes. This is Iris versicolor, setosa, and virginica. This is the sepal and this is the petal. In this dataset, we already have the classes, but the goal of performing clustering is to analyze the numerical values in order to try to identify the clusters. We can open Unsupervised tab. We can find here the k-means algorithm. We just connect the data table to the algorithm. We just need to change here from selected data to data to data. So all the data here is going to be used. If you keep that option selected data, for example, I am selecting only this instance, so only instance number 5 would be used for clustering. We can double-click the components. It is possible to set the number of clusters. For example, we can keep 3 clusters since there are 3 classes in this dataset. After that, we can use the scatter plot to visualize the data. Double-click, we can see here Iris setosa is in blue, versicolor red, virginica green. We can change the visualization. On the x-axis, we have sepal length. On the y-axis, sepal width. We can change here, for example, petal length and petal width. We can see that using these attributes, it is clear to see the separation of the group. If you move the mouse to the instances, it is possible to visualize the data. For example, for this instance, petal length is equal to 3 and petal width is equal to 1.1. To visualize the clusters, we can use a data table component, double-click, see here that there is a new attribute, C2, C1, and also C3, the clusters that have been identified by the algorithm. To evaluate if each flower is in the correct group, we can compare with the original class. For example, most C2 instances belongs to the Iris setosa category. We can now visualize some other clusters. For example, most instances of C3 cluster are in Iris virginica class or category, and regarding C2, they are related to Iris setosa. So it means that it is possible to group and identify the flowers using k-means algorithm. We can also use another component, select rows, double-click, and then we can add a condition. For example, cluster is equal to C1. If you want, you can add more conditions. Then we can use another data table. See here that now we have only cluster C1. It is a very interesting way to filter the data. For example, now we want to visualize only cluster C2. Double-click, we can visualize only instances that belongs to cluster C2. We can also visualize the data using the scatter plot. See here that now we have only iris setosa which are related to cluster number 2. That's all for this lecture, where you have learned how to use k-means algorithm. See you next time! Hello and welcome to this lecture, where you are going to learn a brief introduction to another machine learning task, which is association rules. The most common example for this task is market basket analysis, and it is possible to answer some questions. For example, which shelf should be chocolate chip cookie be placed on to maximize its sales? Grape juice is usually bought with soda. What products can be put on sale? This kind of questions can be answered using association rules. The most famous example is the Walmart supermarket that puts in the same shelves beer and diapers, because they found a pattern that during the weekends both products were sold together. So they put both of them very close in the supermarket in order to optimize the sales. Another applications, promotions with items that are sold together, the example of the diapers and the beer. Plan store catalogs and promotion flyers, so you could use only the products that have more probabilities to be sold. Control dropout of students in universities. It is possible to identify some patterns about the features of the students that may stop the course in universities. So, the university can take an action before the student leaves the course. We can see this image, which is the classic one related to market basket analysis. We can see in this image some supermarket carts with a lot of products, and the idea is to identify patterns. For example, these two products are sold together, so we can put them very close in the shelves of the supermarket in order to increase the sales. This is the basic idea of association rules. The goal is to find patterns in data. In the next lecture, you are going to understand the brief introduction to one of the most famous algorithms. See you there! Hello and welcome to this lecture, where you are going to learn a brief introduction to the a priori algorithm, which is one of the most used to generate association rules. Let's consider the example of market basket analysis, and see here this table with 10 transactions. Each transaction is related to a customer that went to the supermarket and bought some products. For example, the first transaction or the first customer didn't buy milk, bought coffee, didn't buy beer, bought bread, butter, and didn't buy rice and beans. The second client, he or she bought milk, beer, bread, and butter, and he or she didn't buy coffee, rice, and beans. The third customer bought coffee, bread, and butter, and he or she didn't buy milk, beer, rice, and beans. And we have the same structure for each one of the transactions or the clients. The goal is to find some kind of pattern analyzing this data, so we can use a priori algorithm. we have here the same table, and the first parameter is called support, which is the number of instances with x and y. X and y could be two products divided by the total number of instances. As we know, the total number of transactions in this data is equal to 10. So we can calculate the support. This is a parameter you need to specify when working with this algorithm. Let's suppose that the support must be greater or equal to 0.3, which means 30% of the data, considering that there are only 10 instances. For example, we can count the support of milk. It was bought in 1 and 2 transactions. So, the number of instances of x, only one product, is 2 divided by the total number of instances, which is 10. 2 divided by 10 equals 20%. It means that the milk will not be selected in the algorithm because the support is lower than the minimum value, which is 0.3. Now we can calculate the support for coffee. 1, 2, 3, 3 divided by 10 is equal to 0.3. It means that coffee was bought in 30% of the transactions. Now we can calculate for bread. 1, 2, 3, 4, 5. It was bought 5 times. 5 divided by 10 is equal to 0.5. It means that bread was bought in 50% of the transactions. Let's suppose that now we want only the products that the support is greater or equal to 0.3. Milk is not going to be selected. Coffee is going to be selected. Regarding beer, it was bought only twice, so the support is only 20%. Regarding butter, 1, 2, 3, 4, 5 times. The support is greater than 0.3, so it is going to be selected. Regarding rice, it was bought only twice. The support is 20%. And finally, beans was bought only twice, so the support is lower than the minimum value. We can conclude that the products that the support is equal or greater to 0.3 is coffee, bread, and butter. So we can select only them, since let's suppose that we want to generate the rules only for the products that appear in 30% of the transactions. This is the first parameter, and now we need another one, which is the confidence. The number of instances with x and y divided by the total number of instances with x. Again, you need to specify this value. Let's suppose that we want to generate rules where the confidence is greater or equal to 0.8 or 80% confidence. Now, we can select and combine all these products. Let's suppose that for this example, we want to find some rules considering coffee and bread. The first step is to calculate the support of both items together. So we can see here, coffee and bread, they were bought in the first transaction. In the second one, coffee wasn't bought, but bread, yes. This transaction, yes, and here, yes, and yes. So we can conclude that the support of both items, number of instances with x and y, is 3 divided by the total number of instances, which is 10. 3 divided by 10 is equal to 0.3. So the support for both items together is 30%. Now we can create rules considering both attributes. For example, if coffee, then bread. We can interpret this rule as follows. If coffee is bought, then bread is also bought, and the confidence is equal to 100%. We are dividing 3 by 3, or in other words, number of instances with x and y. The transactions that coffee and bread is true is equal to 3. Instance number 1, instance number 2, and instance number 4. 3 divided by total number of instances with x. X is the first product in the rule. In this case, it is coffee. We can see here 1, 2, 3. Or in other words, the support for product coffee. 3 divided by 3 is equal to 100%. It means that every time that coffee is bought, then bread is also bought. We can see here coffee, bread, and coffee, bread. Every time that coffee is equal to yes in the data, bread is also equal to yes. For this reason, the confidence is 100%. The other rule, if bread is bought, then coffee is also bought. The confidence is only 60%. Number of instances with x and y, bread and coffee together. We can see here the first instance, the third instance, and the fourth instance. Bread and coffee are bought together, divided by the total number of instances with x. X in this example is bread. We can see here 1, 2, 3, 4, 5 times. 3 divided by 5 is equal to 0.6. So we can conclude that if bread is bought, then coffee is bought in 60% of the transactions. This is the basic intuition about a priori algorithm for generating association rules. See you next time!
Hello and welcome to this lecture where we are going to implement the a priori algorithm in Orange. To have access to it, you need to click on add-ons and select the associate package and click OK. The package is going to be installed. After the package is installed, we can visualize the new tab, Frequent Item Sets, and Association Rules components. The first step is to select the datasets. There is one dataset that can be used for association rule, which is the market basket. Double-click. The dataset is going to be downloaded. Let's visualize the data using data table components. We can see that it is a very small dataset just to test the algorithm. It is similar to the intuition lectures. Bread, milk, diapers, beer, eggs, and cola. We can see number 1,
which means that the product was bought in the transaction, and the interrogation mark means that the product wasn't bought in the transaction. For example, in the first one, only bread and milk were bought. In the second transaction, bread, diapers, beer, and eggs. There are only 5 instances. We can first visualize the frequent item sets. We just connect the data table to the new component. When we open it, we can see that no frequent item sets have been returned because we need to specify the minimum support. The default value is 30%. Products that appear at least in 30% of the transactions. As this data set is very small, we need to decrease the minimum support, then we can visualize some of the items. You can click this button, so it is going to automatically find the item sets. When you move the component here, see that the result is always the same. We need to double click, and instead of using select data, data to data, it is going to use all the instances of the data set. And now we can better visualize the results. For example, the minimal support equals to 60%, and it is organized by product. For example, the support of bread is 80%. It appears in 80% of the transactions. Bread with milk, 60%. Bread with diapers, 60%. Then we have the other product, the support of milk, 80%, milk with diapers, and then the support for diapers, 80%, diapers and beer together, 60%. We can change here to 100%. The result is empty, since there is no product that appears in all transactions. We can decrease the value, and then we have different frequent item sets. So you can use this component to check the most frequent item sets or products that are sold together. Now we can generate the association rules, connect data table to the component. We need to specify here data to data to use all the data of the data set. Otherwise, only the selected data here will be used. As we can see, there is only one instance selected here, so only this one would be used to generate the rules. Open the component. Now we have both parameters, the minimum support and the minimum confidence. Let's decrease the support and also decrease the confidence. Click on Find Rules. We can see here the metrics, the support, the confidence, and there are some other metrics that are used to evaluate the quality of the rules. We can see here the antecedent and the consequent. If milk is equal to 1, then bread is equal to 1. In other words, if milk is bought, then bread is also bought. And we can see here that the confidence of the rule is 75%. If bread, then milk. If diapers, then bread and diapers, and so on. You can filter the rules by the confidence. For example, if we want more confidence, we can increase the value. For example,
the minimum confidence is equal to 85%. New rules will be generated. You can also set the support, for example, 80%. Now we can decrease the confidence. No rules have been generated. So now we need to decrease the support. For example, 50% and the confidence 100%. If beer is bought, then diapers is bought too. This is how you can use Orange to generate association rules. You need to play with both parameters until you get the desired results or until you find useful rules. The goal of the algorithm is just to generate the rules. And it is the job of the analyst or the data scientist to evaluate if the rules are interesting and if they can be used in the real world. That's all for this lecture. See you next time.
Congratulations for completing the free course, The Ultimate Beginner's Guide to Machine Learning. In this quick and last lecture, I'm going to recap the content that was covered. We start by classification, and we covered 4 different algorithms: naive Bayes, decision trees, rules, and support vector machines. Then you learned how to predict numbers using linear regression, how to cluster data using k-means algorithm, and finally, how to extract association rules using a priori algorithm. All the practical lectures were done using Orange Visual Tool. No programming language skills are necessary. It is important to emphasize that there are many other algorithms and many other techniques within the area of machine learning. In this free 2-hour course, you learned only some of them, as the objective was for you to only have a general overview of the area. After finishing the course, you can decide if you really like machine learning and take longer and more complete courses. We hope you have enjoyed it, and I will see you in the next course.